Okay, teacher. Okay, I'll inform next time.
And when can we do the cover up class? Because we need to complete the syllabus too, na? So one class carries importance. So try to give me your availability, especially in the mornings only. Hmm?
Okay, teacher. I'll try. I'll try.
Okay. Now, what we were doing in last class, and were you able to solve the questions in the tests?
The test, yes, I was able to solve it.
So, how was it?
It went okay, sir. The result came and sent it after the class.
Okay. Yeah, it means you don't have the result with you.
No, no, I have the result. I'll send it after class.
How much?
I,
In chemistry, how much you got?
yeah, teacher, I'm checking. I'm checking. So on WhatsApp.
Hmm. Okay. So,
I
what was
have
the last?
got, oh, yeah,
Mhm.
the last thing that we did, that think enthalpy and discussants.
Yeah, okay. Now tell me how much you got.
Yeah, I got 46 this time and I got 38 last time.
Out of
I
80, 180.
out of 180, 180, 180. Last time I think my center rank was 51. This time it is 30. So I jumped to the 21 ranks.
Oh, okay. Better. So, we did enthalpy, or we have to do enthalpy now?
No, no, we finished enthalpy.
We finished enthalpy. Okay. So can you tell me about enthalpy?
Basically, it
What
is
is
the heat contained. It is, yeah, it is report.
hmm, continue?
Basically, it is the heat contained in the system measured at
Uh,
constant pressure.
what is the formula?
H is equal to U plus PV.
Okay. Chalo. Now, do you have any idea of calorimeter? What is calorimeter? Or how we can do the measurement of delta U and delta H? That comes under calorimetry. I'm sharing you one one theory of bomb calorimeter and the measurement of delta U and delta H. Okay. You just see the theory. I will explain it and then you write it down. Okay. Because bomb calorimeter
Oh,
in this lot of numericals we are getting. So just IMP and a short theory of bomb calorimeter.
okay, sure.
Hmm. Ma'am, please share. Ma'am, मैम शेयर कर दीजिए प्लीज. Received?
Yeah, teacher, I got it.
Hmm.
Yeah, teacher, you are going to explain.
Yes. See, basically, the thing is that in the case of measurements of if you're measuring either delta U and delta H, so bomb calorimeter is there. It is a highly guarded vessel, okay, double walled thick vessel. And basically, in this case, the heat that is absorbed, how it is measured, it is kept at constant volume. And this steel vessel, okay, like we have thermally insulated water bottles now, the thermo flasks and all. So this device, which is made up of steel, this is called as bomb. And we place this bomb in a water bath. Now, why it is placed in water bath? So that entire heat is absorbed and no heat is gone outside into the surrounding. And here we are providing a combustible substances which actually supplies the heat to this bomb, and whatever heat is evolved during this reaction, now that heat actually gets transferred to the surrounding water. Okay, so water, what is the purpose of water bath? The purpose of water bath is no heat is lost into the surrounding. Now this bomb calorimeter is actually totally sealed, so therefore here what do we see? Here we see that volume is also kept constant. There is no change in the volume also. It means that the energy exchange, whatever is taking place between this vessel and this water bath is actually under controlled conditions. Okay, so what we see that these are kept constant, so no work is done. Okay. Okay. No work is done, and no work is done. Why? As the reaction is carried out at constant volume in the bomb calorimeter. So even if we are seeing if gases are there, supposing if we are taking N2 and H2 gas also, here also no work is done. So when your another question comes up that no work is done, now this is a assertion and reason question. Under what condition? When delta V is equal to 0. It means that when the volume is kept constant and the temperature increased, whatever, or you can say the temperature change of the calorimeter is used to find out the heat capacity. Or you can say that the temperature change of the calorimeter, how we can obtain, obtain by converting it into the energy. Okay, how? If we know the heat capacity of the calorimeter. See, in simple words, heat capacity means what? See, supposing we are seeing various these cylinders also, and these cylinders, when they are exposed to high temperature during excessive summer, then what happens? They burst off because they are not, their heat capacity is uh, is more than they can handle it. Okay, so therefore heat capacity of the bomb calorimeter, it can be it has to be known, and on the basis of that only we can find out the Q. Got it? Bomb calorimeter. So in bomb calorimeter, delta V is equal to 0. Therefore, we say that delta H should be equal to delta U. But this is not true. Why? Yes,
That is your.
Neil?
That is your.
We know that delta in a bomb calorimeter, delta V is equal to 0. Therefore, delta H should be equal to delta U. Now, this is true or false? If this is not true, then why?
This is true.
Why?
Because delta V is equal to 0. वो तो true ही है पक्का. Uh, what delta H is equal to delta U.
Mm, no, this is your
H
assertion.
P.
This is your assertion and reason question.
अच्छा. Uh,
Hmm.
statement 1 is true. Statement 2 is wrong.
Yes, very good, very good, very good. Now, in a bomb calorimeter, delta V is equal to 0. So it should mean that delta H should be equal to delta U. But but this is not true. Now, why this is not true? This is not true because the relation delta H is equal to delta U plus P delta V, it holds good only at constant pressure. Okay. And therefore, we know that delta H is equal to delta U plus P delta V plus V delta P. Okay. And at constant pressure, delta P will be is equal to 0. And at constant volume, delta V will be is equal to 0. Got it?
Yes, yes, teacher.
Now, your book is also having a diagram of bomb calorimeter, and I have also given a beautiful diagram of bomb calorimeter.
Yes,
Now, we see delta H. Have you understood this? Have you understood this?
yes, I've understood.
Now, if I see delta H, now this delta H, see measurement for change in heat at constant pressure. Now, this is actually done under atmospheric pressure. Now, this can be done in a calorimeter. How? See, in calorimeter, we know that delta H is equal to QP. QP means heat at constant pressure. And therefore, whatever the heat is evolved, or you can say whatever the heat is absorbed. So heat evolved or heat absorbed, that is QP at constant pressure. This is also known as heat of reaction. Okay, or you can say enthalpy of reaction. Got it? What is heat evolved or heat absorbed? QP. That is the heat of reaction or enthalpy of reaction. And heat is evolved when? Heat is always evolved for an exothermic reaction. So the system will do what? The system will lose the heat to the surrounding. And therefore, the value of QP will be negative. Okay. And delta H of reaction is also negative. So similarly, heat absorbed will be endothermic reaction, and this is positive. Therefore, delta HR will be also positive. Got it? You are
Yes,
writing, Neil?
yes, got it.
You are writing or understanding?
I'm understanding.
Good. Now, we have entropy. Now, what do you mean by entropy? Entropy means what? Entropy actually means a disturbed system. Okay, so we can say the degree of randomness, or you can say disorderness, is known as entropy. Okay. Now the entropy change for a system, that is, you can say delta S for a system will be Q by T. Okay. So if we say that whenever there is Uh, or if I say solid, liquid, and gas. So solid will have more entropy, liquid will have more entropy, or gas will have more entropy. Tell me, what will be the diagram?
Since entropy is the degree of randomness, gases will have more entropy since they have a random structure. They do not have a fixed structure.
Yes. So as we go from solid to gas, entropy increases. Right now, written?
Yes.
Okay. Now what do we see? Now we see the fourth point, that whenever the temperature is increased, on increasing the temperature, volume, mole, or molecule, or either on increasing the temperature or increasing the volume or increasing the mole or molecule, the dissociation, number one. Number two is decomposition. Number three is vaporization. And number four is fusion entropy. All these parameters increases. So on increasing the temperature, all this will increase. Written?
One second.
No. Written?
Yes, done.
Hmm. Okay. Now next we see that, now you will tell me on, next point is on increasing pressure. On increasing pressure, on increasing crystallization, on increasing bond formation, on increasing association. What will happen? Now these are all direct answers. So tell me. Tell me, Neil, fast. You are sleeping today?
Not sure.
Then respond fast.
Yeah, sure. Sorry. On increase in pressure, there will be
Mm.
bond formation.
On increasing pressure, on increasing crystallization. Now, what will happen to entropy?
So the entropy will decrease.
Entropy increases or decreases. Entropy decreases. Good.
Okay.
Then, on mixing two solid or two liquid or two gases. But most important thing, you should always remember that non-reacting. What will happen? Randomness will increase or decrease.
On mixing two solids,
Mm.
randomness will decrease. No, it will increase. Uh,
Yes, very good, very good. Written, should I rub?
yeah.
So when you mix all these things, randomness increases. Now, Neil, you have to now run your mind. Then mobility or randomness is inversely proportional to molecular weight. Right?
Hmm.
If molecular weight of two species is same, then more atomicity indicate more randomness. What more atomicity indicate more randomness? Okay. Now, for example, if I say about if I say H2 is more than N2 is more than O2. For example, if I say C2H4 is more than N2. So, how will you prove it?
Uh, yes, sir. The molecular weight use करके.
Yes, good. Now, next is unit of entropy. What is unit of entropy? See, entropy and enthalpy are very important topic. Unit of entropy is joule per Kelvin or calorie per Kelvin. And unit of molar entropy is what? Joule per Kelvin mole or calorie per Kelvin mole. So we can say that entropy is what? Entropy is an extensive property. Okay. And entropy is a state function. So it is an extensive property and it is a state function. Now, can you explain me this too? Yes.
Yes, teacher.
Explain.
Basically, a state function. Yeah, teacher. Go on.
Yes, yes. Continue now.
Um,
Explain these two statements. Extensive property and state function. Yes.
Basically, an extensive property is that which does not rely on any outer surroundings or surroundings or factors. And state function describes the equilibrium state of a system. Uh, so entropy is an extensive. Entropy is. Do I have to say if it's true or false, or do I have to explain?
No, I was just asking to, explain this statement. That's it.
Okay. So here entropy is the degree of randomness or disorderness, and it is present in almost every substance. Randomness. So it is not exactly dependent on the surroundings. So it is an extensive property. And state function. State function describes the equilibrium states of a substance. इसमें इसमें explain क्या करना है the state function property?
No, what is the meaning of state function that I am asking? What do you mean by state function? And can you give an example, one or two example of state function? How will you describe it?
वही बोला ना मैंने अभी अभी just
नहीं
it
वो
does
ठीक
not.
है. हाँ.
Okay, a state function is a property whose value does not depend on the path taken to reach that
Yes, yes.
specific value.
For example, and any
For
other example?
example, for example, energy,
तो एनर्जी
right?
के अंदर है कि कोई भी रास्ते से जाओ, एनर्जी है वो
हाँ,
एनर्जी की रहती है ना?
हाँ.
सिंपल. ठीक. Okay, good. Now, next is at equilibrium position. At equilibrium, or we can say a reversible process. A reversible process at constant pressure and temperature. Delta S is equal to delta H upon T. Or we can write that delta G is equal to delta H minus T delta S. Right? So what we can write down that at equilibrium, delta G is equal to 0. So we can say 0 is equal to delta H minus T delta S, or delta H is equal to T delta S, or delta S is equal to delta H by T. And total entropy of the universe क्या होती है? What is the total entropy of the universe? Yes.
Yes.
What is the total entropy of the universe? And I'm sharing you one question, neat question. The total entropy of the universe is always, always, always positive. Because universe is always in a state of motion, random motion.
Oh,
Got it?
oh, got it.
Yeah. Check the question which I have given. That is a neat question and do it. Then we will do further 2 more points into this.
Okay.
Done, Neil?
No, teacher, just one second. Yes, teacher. The correct option is option D.
Why option D? Why it is option D?
Basically, first of all, I had to identify the reaction type. उसके बाद I had to
Yeah.
determine delta H. उसके बाद determine delta S. And
हाँ.
then जो भी था ऐसे।
तो इसका ऑप्शन मतलब कैसे किया तुमने, बताओ।
मतलब मतलब हाउ डिड द सॉल्विंग।
हाँ, how you got the answer? Why the correct option? What is the correct option? D, no?
Yes, yes. Delta H, the smaller arrow towards the H is equal to
Very
0. And
good. Neil, fantastic. But tell me how you solved it.
yeah, teacher. So basically, वो पहले तो रिएक्शन डिटरमिन किया मैंने, टू सी
हाँ।
एल जी, Cl2g, वो सब कुछ। फिर उसके बाद आई टू
हम्म।
डिटरमिन डेल्टा एच, मतलब कि
हीट।
अ, वो सब कुछ।
यस। हाँ।
फिर मैंने उसके बाद डिटरमिन डेल्टा एस किया। वो डेल्टा एच के अंदर ऐसा एक्सोथर्मिक रिएक्शन था, तो it involved the formation of bond between two chlorine atoms to form Cl2। वो लिखा था पूरा स्टेटमेंट्स।
हाँ,
फिर उसके
भेजो
बाद
मुझे
डेल्टा।
तुम्हारा।
ओके ओके, श्योर, आई सेंड।
वेरी वेरी गुड, हाँ नील।
या टीचर।
अभी हॉलीडे है क्या इसकी, क्रिसमस की एक दिन?
आई थिंक एक ही दिन है, हाँ।
तो उस दिन हम क्लास रख लें अपनी, पावर अप क्लास।
ठीक है,
2 आवर्स
ठीक
क्लास
है,
रख लें उस
चलेगा।
दिन। थोड़ा जल्दी 7:30। आई थिंक वेडनेसडे ही है ना क्रिसमस।
या वेडनेसडे ही है, तो उसे 2 घंटे का ये है ना।
तो हम लोग मॉर्निंग में 7:30 to 9:30 करें। मजा आ जाएगा पढ़ने में। बोलो, करना है?
ठीक है, चलेगा।
है ना? अभी देख, सही बताऊं, बहुत अच्छा कर रहे हो तुम, रियली वेरी गुड। और इसको रखा ना, तो तुम्हारी लैंडिंग 140 पहुंच जाएगी 180 में से। इतनी तो मेरी
ओ,
श्योरिटी। क्योंकि तुम जो कर रहे हो परफेक्ट कर रहे हो, खाली लास्ट क्लास में यू कुड नॉट डू 2-3 क्वेश्चंस।
हाँ वही,
है ना?
नींद आ रहा
हाँ।
था।
है। हाँ, नहीं, इसीलिए ना, आंखें खुली भेजा खुला सब खुला
हाँ।
होना चाहिए। चलो, मैंने
हम्म।
मैडम को एक क्वेश्चन भेजा है, वो भेजेगी तुमको। एंड वेरी गुड, आई एम वेरी हैप्पी, सेंड मी योर आंसर।
या टीचर, आई एम सेंडिंग, इट्स टेकिंग सम टाइम आल्सो।
ओके फाइन। मैडम भेजिए उसको। और ये 4 क्वेश्चन और भेजे हैं, दे आर फैंटास्टिक। आ गए तुम्हारे पास?
हाँ, आ गया। I'll
फटाफट कर।
can I do one thing? I'll solve this question also and then I'll send उसके बाद दोनों एक
हाँ
साथ,
हाँ,
क्योंकि ये टाइम
ठीक
लग
ठीक।
रहा है। टाइम लग रहा है ये।
हाँ, तो टाइम मत वेस्ट करो तुम काम, इसलिए मैंने तुरंत भेज दिया, तुम करो।
ठीक है।
हो गया नील? नील?
Yeah, teacher, almost हो गया. I'm on that stretching of a rubber.
ठीक.
Yeah, teacher, I'm sending it through Susmita ma'am.
Okay, okay.
Yeah, Susmita ma'am have sent.
I'll check. I'll check. I'm not received.
Okay.
हाँ तो यू टेल मी द आंसर्स ना, मैडम भेजेगी तब तक देखूंगी मैं. फर्स्ट का
ठीक है,
आंसर क्या
ठीक है.
है?
फर्स्ट का मैंने लिखा है इंक्रीजेस, कि वैसे
तो
टेम्परेचर इंक्रीज तो ये भी
पॉजिटिव.
इंक्रीजेस. और पॉजिटिव, यस.
पॉजिटिव.
फिर
वाह यार.
सेकंड का
हम्म. सेकंड का
सेकंड
क्या
का
है जल्दी?
डिक्रीजेस, नेगेटिव. नेगेटिव डिक्रीज.
वेरी गुड. क्या बात है. थर्ड का?
थर्ड का ये ऑल्सो पॉजिटिव.
वेरी गुड. क्यों है पॉजिटिव?
पॉजिटिव ही है क्योंकि उसका टेम्परेचर इंक्रीज हो रहा है ना, तो रैंडमनेस भी इंक्रीज होएगा.
भाई तुमको कैसे समझ में आ रहा है इतनी जल्दी जल्दी भाई? वेरी गुड. फोर्थ?
फोर्थ भी ये पॉजिटिव आई थिंक. तो उसका स्ट्रेच करे तो उसका रैंडमनेस ये होएगा.
ओके.
यस.
वेरी गुड.
फिर उसके बाद रस्टिंग, फिफ्थ ऑप्शन का ये नेगेटिव डिक्रीज.
फिफ्थ ऑप्शन नेगेटिव?
हाँ.
नहीं. इससे बताओ।
डिक्रीज होएगा ना।
रस्ट, नहीं, रस्टिक आयरन में क्या होता है, मेटेलिक बॉन्ड इज प्रेजेंट ना आयरन एटम्स में।
अच्छा।
To rusting there is bond dissociates, so therefore delta S will be positive.
ओके श्योर।
ठीक, कोई नहीं, गुड। केमिस्ट्री में क्या करना है, केमिस्ट्री के अंदर घुसना है, घुसोगे तो अपने आप ही आंसर आ जाएगा। चलो, और एक और भेज रही हूँ मैम के साथ में, क्योंकि इससे बेस्ड बहुत सारे क्वेश्चंस हैं, देखेंगे। तो वो जब तक भेजती है तब तक देख लेना। एंड तो अब नेक्स्ट पॉइंट क्या है, लिख लो कि टोटल एनर्जी ऑफ द यूनिवर्स इज ऑलवेज पॉजिटिव, सो हम क्या बोलेंगे, डेल्टा एस टोटल will be more than 0. Okay, so delta S of a system plus delta S of surrounding is less than, is more than 0. Hmm?
ओके।
More than 0. And at equilibrium, position, total entropy change is 0. So we can say that delta S total is equal to 0. That is delta S of system plus delta S of surrounding is equal to 0.
ओके।
ये याद रखना है। देखो मैम ने भेज दिया तुमको।
जस्ट वन सेकंड देखिए।
हाँ, वेरी गुड। हाँ, परफेक्ट तरीके से तुमने आंसर लिखा है।
थैंक यू।
सो एक आइडियल क्रिस्टल है, उसके अंदर में क्या होता है, उसके पास में परफेक्ट ऑर्डर है ऑफ इट्स कॉन्स्टिट्यूएंट पार्टिकल्स। एक रियल क्रिस्टल है, उसके अंदर में लेस ऑर्डर होता है। क्यों, रियल क्रिस्टल में कुछ डिफेक्ट्स होते हैं। तो रियल क्रिस्टल के अंदर में डिफेक्ट्स होते हैं, देयरफॉर अ रियल क्रिस्टल हैज मोर एंट्रोपी देन आइडियल क्रिस्टल। A real crystal has more entropy than ideal crystal. So इससे हमको क्या मिलता है, सेकेंड लॉ ऑफ थर्मोडायनेमिक्स। सेकेंड लॉ थर्मोडायनेमिक्स का क्या है, टोटल एंट्रोपी is total entropy change is always positive for universe. Okay, so for a spontaneous or irreversible process, स्पॉन्टेनियस प्रोसेस के लिए क्या होगा, क्योंकि वो कंटिन्यूअस हो रहा है, सो उसके अंदर में एंट्रोपी चेंज विल बी ऑलवेज पॉजिटिव। ओके,
यस ओके।
ओके, सो delta S of the system plus delta S of surrounding is more than 0. ओके, सुनील बहुत अच्छा कर रहे हो, वेरी गुड। अब इसके बाद है ना, हमारे पास में दो तीन ये क्वेश्चंस मैंने तुम्हें दिए हैं, और फिर हम लोग फटाफट क्वेश्चन करके नेक्स्ट क्लास में ना कार्नोट साइकिल चालू करेंगे।
ओके श्योर।
ओके चलो, तो वेडनेसडे को हम लोग पढ़ेंगे 7:30 to 9:30। बिल्कुल भी चेंज मत करना और आंख खोल के बैठना। बहुत इंपॉर्टेंट टॉपिक चलेगा, क्यों थर्मोडायनेमिक्स हमारा फिनिश होगा।
ओके।
और या तो अपना 12th का भी करना है ना, एक 12th के चैप्टर क्लासेस नहीं हुई है तुम्हारी एचएससी की,
हाँ। ओके। सो
है ना, तो अपन मैनेज कर लेंगे। चलो बाय।
बाय। बाय मैम।